So looking at number 13 from page 167. Take a derivative, set it equal to 0, see if there's any places where it's undefined, and that will give us our critical numbers. So G prime, again, you can do what I'm doing, just be careful because this G prime is different than this G prime, right? Because this G is the overall G and this G is part of the product rule. Like, it's fine, just be careful because it's not technically correct, but as long as you can keep up with it, you'll be all right. So let's see, first one times the derivative of the second one. And I'm going to kind of do a little bit of algebra on the fly there. So 4 minus t to the negative 1/2 is a square root in the denominator. Plus the other way around, so that would be 4 minus t to the 1/2 times 1, or just square root 4 minus t. Let's see, so negative t over 2 square root 4 minus t plus square root 4 minus t. Now I want to know where that's 0 and where that's undefined. I can see where it's undefined, I think, really easily right now. Does anybody see what value of t would be a problem? Can't divide by 0, so 4 won't work. So t equals 4 is not going to work. So f prime undefined at t equals 4. Because that's going to make this denominator 0, and we can't do that. I also want to set it equal to 0 to find what would make it 0. And I think the easiest way to do that is going to be with a common denominator. So 2 square root 4 minus t, top and bottom of the second one. This is now just an algebra problem. I just need to clear up all the algebra stuff. So negative t plus 2 times 4 minus t, because square root 4 minus t times square root 4 minus t is 4 minus t, all over the denominator. And in some sense, the denominator doesn't matter because the only thing that makes a fraction 0 is if the top is 0. So negative t plus 8 minus 2t and again, the denominator doesn't really matter for what I'm going to do. So negative 3t plus 8 equals 0. T equals 8/3. So that's G prime equals 0. G prime undefined happened at T equals 4. So those are my two critical numbers. Although, if I go back and reread the start of this question, one of those is no good. Pardon? Why? Yeah, at the very beginning it said t has to be less than 3. So any answer that's not less than 3 I can throw out because we're not really looking at that anyway. So we only have one critical number, 8/3. All right, the rest are not just, like it's easy, but the rest are absolute extrema questions. So let's do maybe one of those. So starting at 17, anything? $25 would be quotient rule. 29 is absolute value. 33 is trig. 37 is just a line. 41 anything stand out to you from the... Okay. So the absolute value one was number 29. So we're looking for the extrema on y equals 3 minus absolute value of t minus 3 between -1 and 5. All right, so remember, here's our process. Critical numbers lead us to a table, lead us to knowing the extrema. Critical numbers is where the derivative is 0 or undefined. I don't really want to take a derivative with an absolute value, though, because that would be a pain, a real pain. Based on what you know about absolute value, where is there a critical number for an absolute value graph?
0. Well, at the origin.
Great answer. Well, maybe not at the origin, just in general. Yeah, good. At the V thing, right? Like, I don't know about this particular absolute value, but generally speaking, absolute value has a cusp. And a cusp means f prime is undefined. So forget about taking a derivative and really even graphing this whole thing. If I can figure out where the cusp is the only place where the derivative is 0 or undefined. So can we figure out where the cusp of this graph would be? Any thoughts? Do you know where the cusp is? Go ahead. What do you think?
X equals 3.
Good. Well, t equals 3, but yes. Whatever makes this 0 is where the turn happens, where the cusp happens. So there's a cusp at t equals 3. So I'm kind of going a different way to find the critical numbers for this one. I'm not taking a derivative. I'm using what I know about derivatives and what I know about absolute value to come up with there's a critical number at t equals 3. Because that's where and who knows, maybe it's upside down, but there's a cusp there.
Could you think about it like a graph, like how you move it to the right 3 because it's inside the...
You can definitely think of it that way. This is a shift to the right 3, and so that's going to move the cusp right 3.
So you only have to find the x value, so it doesn't matter where it is up and down.
Right, it's flipped upside down, it's been moved up 3, but don't really care about that. There's a cusp at t equals 3. So my table of values then would be my endpoints and my critical points. So critical points 3, the endpoints are -1 and 5, and from there it's just plug in and see who's biggest and who's smallest. So it's just careful with absolute value stuff. -1 minus 3 is -4, but absolute value that would be 4. So -1, -1. At 3, 3 minus 0 is 3. And at 5, 3 minus 2 is 1. And then let's read our question carefully, because there's this whole thing about the x location is the where, the y is the what. So let's make sure we answer find the absolute extrema of the function on the enclosed interval, on the closed interval. So it doesn't really specify, so I'm probably best to give the point. So there's an absolute max at, let's see, that would be 3, 3. Again, if you give the full point, you're safe. And there's an absolute min at -1, -1. We're 10 minutes into the homework and we've not taken a derivative yet. Because it's all been, I mean, we've thought about derivatives, but we haven't really taken one yet.
We did definitely take
Do we want to do one where we take one?
one. We already did.
We did?
You do 13.
We did it for
13 have, oh yeah, 13 was product rule. I was thinking of number 9. You're right. Critical numbers lead us to a table, lead us to extrema. At least that's the way we did it today. In the future, instead of a table, we've got a first derivative test and a second derivative test that we'll do, but that's not yet. Anything else from 167?
Can we go over it tomorrow for the questions? Or we didn't Friday?
Probably.